This session we discuss about conjunction as our next logical connective. So let P and Q be two statements. The conjunction of P and Q denoted by is a statement P and Q the statement P and Q. So e.g., if we have P is a statement Earth is the closest planet to the Earth, to the Sun, and we have Q, 3 plus 6 equals to 10 are two propositions, then the conjunction of P and Q in the statement Earth is the closest planet to the Sun, and 3 plus 6 equals to 10. So the key word is and. If we have another example, number 2, it is raining, and B, root 6 is an integer. Then the conjunction A and B will be, it is raining, and root 6 is an integer. Example 3, if we have M is a proposition, sugar causes tooth decay, and we have a proposition N, Nairobi is the capital city of Kenya. Then the conjunction of M and N will be sugar causes tooth decay, and Nairobi of Kenya. Now, to be able to draw the truth table for the conjunction connective, we use an example of series arrangement of bulbs. So let's have a switch there, and let this let's have one switch there, another one here. Then we have a bulb. So series arrangement. So let this be proposition Q and this P and then this one Q. So series arrangement helps to understand the way we draw the truth table for conjunction connective. So this is the truth table. So this be P, this is Q. And so this is the P and Q. So true, true, false, false. And then there you write true followed by false, and then true followed by false. Now, as we said in our earlier discussion, if you have two propositions, then your table will have 4 rows. So 1, 2, 3, 4, 2 power 2. So usually with two propositions, the first column or the first proposition you write true, true, false, false, and then in the next one, you alternate true, false, true, false. Now, with this analogy, if you close, so true will mean closing the switch for P, and true for Q means closing switch for Q. If the bulb lights, then we illustrate that one by true. If the bulb doesn't light, we illustrate that by false. So if it's close switch P and you also switch close switch Q, then obviously this bulb will light because we'll have a closed circuit. So this will say true. True for P means you close P, but false for Q means you leave this one open. At the end of the day, this bulb will not light because we have an open circuit at Q. So not lighting is F. This means you leave P open, close Q. Because we have an open circuit here, then the bulb will not light. False, false for P and Q means this remains open, this remains open. So we have open circuit. So this is incomplete, so the bulb will not light. So we'll have false. So that is how we draw the truth table for conjunction. So note, the conjunction P and Q is true only if both P and Q are true, otherwise P and Q is false. You can see from this table here. And what helps you to understand how to fill this table is the analogy of series arrangement of two switches, P and Q, where P and Q are the propositions, and we have a bulb. So once bulb lights, you give it value T. If bulb doesn't light, you give it value F. And you'll see that in a series arrangement, the bulb can only light when both the switches are closed. And so that's why only the first row TT will give us truth value. All others are false. The next session we'll be discussing about the next logical connective, the so-called disjunction. Thank you.